Okay, hey everyone. Hopefully this video will work okay for us. We're going to go really low tech on this and just do a normal sheet of paper. So this is the example from the Jamboard where we're looking at this pedigree up here and we're trying to figure out, is this a dominant or recessive inheritance pattern? So I've circled the part of the family that we were talking about, where we noticed that we had two unaffected parents with an affected offspring. So whenever you're looking through the pedigree, always try to find two parents that are the same that have a child that is different. And I'm going to show you why it is the case that we can assume that this is recessive. So I'm going to show you each possibility, if it was recessive or versus if it was dominant, and then show you why it can only be one of these. So if we are going to assume that it's recessive, we're just, for the sake of our argument, let's assume that this is recessive. That would mean that we're talking about the shaded individuals being recessive, or the shaded individuals are affected and the affected disease is a recessive disease. So we're going to assume then that our shaded individuals have to be homozygous recessive. It's the only way they would show a recessive trait. Okay, so if that's the case, we have to see, is it possible for these parents to have dominant alleles? Okay, so can we assume then that these parents would be heterozygous or homozygous dominant? And you'll see if we do a Punnett square, if we do this Punnett square, you can then see here that it is possible to have this recessive offspring or an affected offspring, if we assume that it's a recessive trait, with two unaffected parents, if these are their phenotypes here. So it is possible. You can have an affected offspring with two unaffected parents. And we would call those parents carriers if this was a recessive trait, okay? Let's just go on for argument's sake to see, is this also possible if this were a dominant trait? So if we're assuming that the trait is dominant, okay, the shaded is dominant, then that would mean unshaded individuals were heterozygous recessive. Okay, so if the trait is a dominant trait, that would mean that these unshaded individuals or unaffected have to be homozygous recessive because they're not showing the trait at all. If the dominant allele is there, you'll definitely show that dominant allele. Okay, so if they're not showing it, then they can't have a dominant allele. So that means we're assuming these are homozygous recessive. If this is a dominant trait, then to get this, to show the trait, you would have to have heterozygous or homozygous dominant alleles. So is this possible? Are you able to have two parents that are unaffected and therefore homozygous recessive and still get an affected offspring with a dominant trait? So hopefully you can clearly see from this Punnett square that that's not possible. Okay, so it's not possible to get a dominant allele here. So that means that if we had two unaffected offspring or two unaffected parents, you could only have unaffected offspring. So two unaffected parents must only have unaffected offspring if the trait is a dominant trait. Okay, so if this were a dominant trait, you can only have affected offspring if you also have an affected parent. So two unaffected parents can't have an affected offspring. It's not possible. So therefore, we know that it is not a dominant trait. It can only be recessive. That's the only way we can see this pattern here. Two unaffected parents with an affected offspring. Okay, so hopefully that shows you how you can prove for sure that it is recessive or dominant. So as you can see, this was kind of like a sneaky example. It shows up in every generation still. That's not typically what you see with a recessive trait. However, it is absolutely still possible. Okay, it's absolutely possible to still have it show up in every generation. So that would mean here, if this is recessive, okay, that would mean this mother is a carrier, so that all these two children could still end up recessive. Okay, so all of those genotypes are still possible if it's recessive, even though it's uncommon. It's not a way to prove for sure that it's dominant. Okay, so jump back in the Google Meet if you have any questions, or send me an email or a comment or something like that, and I can hopefully clear some things up.